Hi, this is the YouTube channel for Math Contest Go Go Go. What I want to do for this channel is to build a platform for math lovers in order to make them discuss about different kinds of math problems. I will update a video about challenging problems every day. If you would like, please subscribe below.
Hello. We are going to talk about something more about derivatives this week. We are going to talk about the following, which is the trigonometry, derivatives, inverse trigonometry, the chain rule, and the exponential rule. This is the four things we are going to talk about. Trig derivatives. Okay, just remember the formulas. It is actually, you can also able to infer them through the, what's that called? The basic definition of derivatives. X is equals to secant square x. Sec x is equals to negative CSCX COTX. Secant x is secant x tangent x. ddx cot x is equals to negative secant x CSC square. Okay, so these are the formulas of trigonometry. Okay. Let's continue to talk about the chain rule. What is a chain rule? As we know that when we talk about the rules of exponential, like this only works if it is a single integer. So what does this mean? This means if there is one formula like this. Let me think. If there is a 3x, if it requires you to find the derivative of this, what should we do? So in this case, you have to set this as u. And you need to time another du over dx there. This is called the chain rule. So if you find that in this case you are solving it like you are actually solving a complex derivative that cannot be solved via formula directly. So you have to apply the, what's that called? The chain rule here. I mean, you have to substitute one as u or some number else, and you time the one by du over dx, which is the derivative of it. Okay, so let's do this. So we first set this as u, which is this. And then we time the derivative of this out there, which is 3. And we change this into this. So we get this. And remember, you need to put this back ultimately. And this will be the final answer for this. 12 times 3x plus 6 cube. So this is what I think is very important. Okay, so I'm going to give you a very complex problem, which is in sine x4. Sorry, in sine cos. Okay. So in this problem, it is require you to find the derivative. Well, you can see that it gets really complex. So in this case, we apply the chain rule, x out the outside, so it's 2x. And we then do the derivative of this. 2x times in sine, what's that called? Sorry, you have to start from the exterior, the most outside one. So it's like you are timing it with in times in, it's like the derivative of this. I mean, by formula, you set this as u, so it will be this. But in this case, you need to time this as the derivative. I mean, the derivative of this. How to get the derivative of this is that you need, in this case, you need to set this as u. And you get the derivative. The derivative of this is cosine x squared plus 7. And then you need to time the derivative of this, cosine of x squared plus 7. The derivative of this is this. But now you need to set this as u, and you need to calculate the derivative of this again. So you need to time 2x at last. So the final answer for the derivative of this is this times this times this times this times this. It will be a pretty long derivative, right? Yeah, so using the chain rule, you need to set if it's a complex one, and it can be used, you need to use substitution way to like substitute some complex part as a certain alphabet, and then you need to calculate the derivative of that complex part of derivative. You understand? So it means that you need to calculate, when you do a derivative that cannot be solved directly through formulas, then you need to set some hard parts as a certain alphabet, like u. Then you need to, but when you actually using the way, you successfully get the derivative, then you need to time the derivative of the part you are substituted. Okay. Hope you understand. This is the rule, chain rule. The next thing we are going to do is, so this is the exponential rule. You just need to remember. We can actually try another problem here. In this case, this is not a simple number. It should be substituted because it's not a single variable. So e to the power of 3x, right? E to the power of 3x. So the derivative of it is this. But you need to take this out and times the derivative of this, which the final answer is du over dx. Okay. So this is a chain rule if it's not clear. So in this case, when you are actually doing ax with any number. So the formula for this is this times ax. So this is the formula. Okay. So give you 3 seconds and see whether you can find the answer for this or not. Give you 20 seconds. 16, 15, 14, 13, 12, 11. Okay, time is up. So we know using the formula, we can get this as a direct formula. However, you need this to be differentiated. So in this case, this needs to take out, and it should be timed by 2, the derivative of this. So the final answer for this is this times this. Okay. The last thing we are going to talk about is the derivative of inverse trigonometry function. Okay, you will find this is okay, so for these things it is like this. Okay, I'm just going to dx tangent -1u. Dx CSC -1u is d dx secant -1u. COT -1u. So these are the 6 formulas for trig derivatives. Okay, so this is the end of this week. I hope you learned a lot of things here. See you next week. In fact, problems, they have many solutions, and my solution is only a part of them. If you have more challenging solutions, please comment below. And don't forget, I will also post my problems there. See you tomorrow!